Alright, so today is 11:4. We are looking at Chapter 3, Section 5. And we're going to be solving one-step inequalities. With multiplication or division. Okay, so when we review where we've been, when we have one-step inequalities with addition or subtraction, all right, we solve these exactly the same as equations. That's what we talked about last week. How many of you guys are cool with that? Right? Okay. Now, the difference here is, all right, when we have multiplication, let's first of all talk about multiplication. What does the word coefficient mean? What does the word coefficient mean? You guys have to know this. What's a coefficient? Brendan?
The number that's multiplied by.
Excellent. Yep. This is the number that the variable is being multiplied by. So if I have something like, for example, 3x, that 3 is the coefficient. All right, you guys cool with that? Okay. So, if we have something like this, x divided by 2, what is the coefficient? And it's not 1. What's my coefficient? Sarah? It's not 2. AJ? Remember, what are we multiplying that x by to get that? Not 2 over 1. Is there a 1 right here? So what are we actually multiplying our variable by? How can I rewrite this showing a coefficient? Ada? Not 1x. Can't forget that 2 in the denominator. Molly? Nope. This is not 2 over 1x. I'm not saying what am I multiplying this by. I'm not asking for the reciprocal of this. I want to know what is the coefficient of that. I know this is hard, you guys. We've talked about this once before. Addison? No. This says 1 times x divided by 2. How can I rewrite this as some number times x? Sophia? Nope. 2 times x is not this. Amanda? Yes, this is 1 over 2 times x. So x over 2 is the same thing as 1/2 times x. How many of you guys are cool with that? Because if I go to multiply this x is like x over 1. And if I'm multiplying fractions, aren't I multiplying numerators and then multiplying denominators? Does that make sense to you guys? Yes, kind of? Okay, I need you to understand that. All right, so if I give you x divided by 2, technically that 1/2 is the coefficient. You don't have to change it into 1/2 times x. But I need you to recognize that that's what this means. Because that coefficient is the key to solving these. Okay, so now let's talk about when we have inequalities with these coefficients. Are you guys cool so far? Okay, so solving inequalities with multiplication and division. All right, we solve exactly the same as we do equations. There's just one small change. All right, so we're going to solve exactly the same as equations, except if the coefficient is negative, we flip the inequality symbol. That is the only change. If the coefficient is negative, we flip the inequality symbol. That is the big part. So let's take a look at what the heck I'm talking about. So I want us to solve the following inequality. Who needs to see what's up there? Okay, so let's solve negative 10t is greater than or equal to 34. Okay, how am I going to solve this? We solve it exactly the same as we would an equation. So how do I solve this inequality? Cameron? Yep, I'm going to divide both sides by 10 because this says negative 10 times t. Okay, so when I do that, Cameron, my negative 10's cancel out. I'm left with a 1t, right? Excellent. What is 34 divided by negative 10? Cameron? Excellent. This is negative 3.4. So it's at this point that we need to look at the coefficient to see if it is negative. If so, flip the greater than or equal to less than or equal to. So, someone tell me, am I going to flip the inequality here? Am I going to flip the inequality? Matthew? Yeah. It's a negative coefficient. So this greater than or equal to becomes less than or equal to. You cool with that? All right. Now, the reason I focused on the coefficient and that x over 2 is the same thing as 1/2 times x is because in your book they have something like this. I want to solve m divided by 3 is greater than 3. Right now, remember, coefficient is a number the variable is being multiplied by. But if I don't clear up for you that this m divided by negative 3 really is a negative 1/3 times m, I can't use that same statement, that it's a coefficient. All right, but as you can see here, m is being divided by a negative 3. That is considered your coefficient. So negative 1/3 is the coefficient. That 3 that m is being divided by is negative. So I would need to flip here. So someone tell me, what do I multiply? What do I do to solve this? M over negative 3 is greater than 3. What do I need to do to solve this inequality? Come on, it's the same thing as if this was an equation. Amanda? Excellent. I'm going to multiply both sides by negative 3 or negative 3 over 1. My My negative 3's cancel, and I'm left with a positive m. Amanda, what's 3 times a negative 3? Negative 9. Do I flip that inequality, Amanda? Yeah, because that m was being divided by a negative 3, or the coefficient was a negative 1/3. Are you guys cool with this so far? So I'm going to give you a couple that I want you to solve, and then we're going to talk about a story problem. You guys cool? Yeah. No, do not flip it in the beginning, because when we do two-step ones, that could change depending on what I'm doing. All right. So you always wait until you get to the point of multiplying by that negative coefficient or dividing by that negative coefficient. That's the step in which I want you to flip it. Does that make sense? Yep. So when you show I'm multiplying both sides by negative 3, when you write your solution, that's when it's being flipped. Okay, it's a great question. All right, so I want you to solve a couple of these. Remember, the coefficient has to be negative. It does not matter if that constant on the other side is negative. All right, so I want you to solve the following inequalities. So n divided by 6 is greater than negative 7 is the first one. Go ahead and get going, please. So those are the 3 that I want you guys to solve. You do not have to graph them. Remember, when you're doing these, you're always looking at that coefficient. You don't care if that constant on the other side is negative. It's only the coefficient that determines if you flip it. When you're done, check what people buy you. This should not take you too long. You guys, when you do a T, make sure it has a little hooky job at the bottom of it, right? Don't make it look like a plus symbol. See how mine has the little candy cane hooky job on the bottom? Just do that, please. Okay, someone tell me what to do on that first one. Valentina? Excellent. Do I flip the inequality? No, why? Correct. Excellent. Someone do the second one for me. Addison? Excellent. Awesome. Did you have to flip the inequality? Why? Because what's not, say that again? Excellent. The coefficient's not negative. How about that last one? T divided by negative 4 is less than 3. Cullen?
You multiply negative 4 over 1 to both sides.
Excellent.
Here I got T is greater than negative 12.
Excellent. Why did you flip the inequality?
Because negative 4, the coefficient was a negative.
Excellent. Yep. All right, so let's talk about story problems. You guys, what indicates when we have multiplication in story problems? What are some of the things that might indicate that we have multiplication in our story problems? Ada? Yeah. So when we talk about multiplication, you're always looking for a rate. Always looking for a rate. What comes with the rate is there are two different units of measure in the problem. Another thing that we could see is 4 times as much. That's something that we saw in our test. That indicates multiplication. All right, we are still doing parts equal to our whole, where our whole is a maximum or minimum total, and our parts are the actual we are doing. So that's the same whether we're adding or subtracting or multiplying or dividing. All right, so let's do a story problem. All right, I'm going to show this to you, and I want you guys to write this information down, and then we're going to do it in this example that we're doing. All right, it's going to be talking about Canadian geese. So write down the information that you need. And we're going to talk about how we know it's an inequality. It says some flocks of Canadian geese can fly nonstop for up to 16 hours. In this time, a flock can migrate as far as 848 miles. At what average speeds can the flock fly during migration? All right, so write that information down. And then once we do that, let's talk about how we know this is an inequality. Okay, so these are the things that I wrote down as kind of bullet points. I don't write down everything if I don't have to. Here are my givens. We have geese. They fly up to 16 hours migrating. They fly as far as 848 miles. We want to find the average speeds. What things in here indicate that it is an inequality? Because I think there's a couple things in there. Molly? Yeah, those two right there indicate inequality. There's one other thing that indicates inequality, but those definitely do. There's one other thing in there, AJ. Not average. Average. Is it speed or speeds? Yeah. There's more than one possibility. If they said average speed, and they just said they fly 16 hours, they fly 848 miles, that's an equation. But all of these individual things, that also indicates an inequality. All right, do I have a rate here? If you don't recognize you have a formula that you're using, and that's fine if you don't, do you have a rate here? Matthew? What is it? No. Where is a rate up there? Not can you create a rate. What information, you're saying there is a rate. What information is the rate up there? No, that's time. Do I have a rate in this problem? Valentina? I don't see any miles per hour up there. Be more specific. What is my rate up there? Not how do I write my rate. Do you guys see a rate on that screen? How many of you guys do not see a rate on that screen? What are we looking for? What are we looking for? What is it that we're looking to find? Sophia? What is that? What is an average speed? Brendan? What is that?
The rate.
That's a rate. Here is our rate. They didn't give us a rate. We're looking to find the rate. The rate is what's missing. So we do have a rate up there. It's just what we're trying to find. That is the rate. All right? So you need to recognize sometimes the rate is what's missing, but we have a rate up there. All right. So what is my game plan? You could remember that there's a formula that goes with distance, rate, and time, or you can just remember parts equal to your whole here. All right, what is my game plan here? Cameron? So let's not worry about the greater than or equal to or less than equal to. Number of miles traveled, that's going to be my whole, right? Do you agree with that? Excellent. What are my parts? How do I find the miles traveled, Cameron? So number of hours times, yep, so miles per hour. So there are my parts, there is my whole. Okay, so Cameron, that miles, those total miles, according to our statement up there, are those a maximum they're going to go or a minimum they're going to go? That's a maximum because they go up to. So that is a maximum. So Cameron, what can our actual, so this on this side is the actual distance. This is our max distance. So what can our actual distance be, Cameron, in relation to the maximum? Are they going, if this is a maximum, are we actually going more than the 848, or are we going to be going less than? It has to be less than. You guys, it's a maximum. So what we're actually doing has to be smaller than our maximum. How many of you guys see that? So what we are doing is smaller than our maximum. So the smaller side is facing our actual. Can they go exactly 800, that maximum? Coral? Yeah. That's an equal to as well, because it goes as far as that maximum. All right, so now I'm going to go ahead and write this. I have 848 is greater than or equal to the actual of, I'm going to give R to my rate, 16 times R. So that is what I need you guys thinking. Our actual distance must be lower than the maximum, or equal to it. That's your thought process when you're figuring the inequality symbol part of it out. How do I solve this now? Alex, how do I solve this? Excellent. So I'm going to grab your calculators. All right, so we're going to do 848 divided by 16, and I get my R is less than or equal to, I flipped it around. Can you guys see this? Like I didn't flip the inequality symbol, I'm just flipping the order. I put my R going first, is less than or equal to 53. So the geese fly up to 53 miles per hour. You guys cool with that? You guys good? All right, so I really need you guys thinking about do I have a maximum, minimum, and then what is my actual, in this case, distance in relation to my maximum distance. You guys cool? All right, all of you can go because we're running late. Take all your stuff with you.